Hello, everybody. My name is Nicholas. I'm a data scientist for the Data Incubator, which is the company that's partnering with World Quant University to bring you this data science course. If this is the first time you are joining us, welcome. I'm happy you're here. I see some new faces here, and I see some old faces in the chat screen. So I'm very excited to get started. How is everybody doing? Where's everybody writing us from? I see Robinson is joining us for the first time. Welcome, welcome. Maggie's back. Grace is here. Anise is talking to us from India. This is great. Wonderful, wonderful. Chung is saying hello from Vietnam. Florine from Romania is here, and they finished the first exercise of the PW mini project. It's 7 p.m. in Uganda, according to Kagumire or Kagumire. Okay, good. All right. Let's get started, everybody. Oh, wow. Joseph is calling from Malta. Malta, hello, hello. I think you might be the first person to tune in from Malta, so welcome. Robinson's in Uganda. We have some people from the Philippines. Mehdi is from Algeria. Elena is here calling in from Russia. Rakesh wants to know if there's going to be a surprise exam in this course. The answer is no, there are no surprises. Ariel is calling in from Qatar. Hello, hello, Qatar. I hear a lot. Oh, Rinky is back from Boston. A lot of questions about k-means clustering, I see. Okay, so I already see some questions here in the chat room. I see some people asking about exercise 1 of the PW mini project. What else? What else? And also k-means clustering. Okay. Tell me, what other questions can I answer for you guys today? What else is on your mind? What else is percolating? IP exercise 5. Okay, that's one. Let me check that out. The famous sieve. Maxwell's tuning in. It's their first time. Elena has a general question. They want to know what are the necessary topics for comprehensive data science self-education. Well, I think this is a first good step, right? I think a lot of what we're covering in here is going to be a really good base. And then I think Unit 2, on top of that, would be an excellent follow-up. So I guess I would start with those. And if you wanted to do like a super comprehensive self-study, I would say, yeah, sure, some linear algebra, a little bit of calculus, some probability, Statistics is very important, and then programming, specifically in either Python or R. Vin kind of wants to know if they can complete the exercises, the mini projects. They have to go week by week, or if they can do it all at the end of the course. You can do it all at the end of the course. I don't recommend it. I would say go incrementally so you don't get slammed at the end. Heisen has some questions about Unit 2. Okay. What specifically about Unit 2? Is it like a mini project or a certain part of the lectures? Let me know. Rinky's interested in the k-means clustering, but it's difficult to implement. Rinky, what notebook are you looking at? Let's see here. I see Joseph is looking at VC distance. Let me grab that one too. Okay, so that's the object-oriented one. So that's this week. Okay, Elena has a great question about default dictionaries. All right, so I'm going to start with default dictionaries. And then I'm going to look at the... Okay, so Rinky's on the VC mini project. Great. And we can look, I think, at the PW mini project today. And if we have time, we'll look a little bit at the VC project as well. Okay, good. So we have a plan for today. All right, let me get started then. All right, the first thing I'm going to do is I'm going to share my screen with you guys. And this is the Pi Data Structures notebook that's in that's on your servers. And I'm going to scroll down to the collections part, which is and then I'm going to go all the way down to default dictionary. Now, one thing that I do when I am looking at so the first thing is that the Python standard library comes with this module called collections. So if I look for the let's see here, let's look for the documentation. Okay, beautiful. So if you're interested in learning more about the collections, the tools that are available to you through collections, and this is a great series of tools, I recommend going to the documentation. Let's talk about default dictionaries. So the cool thing about a default dictionary is it works as a dictionary, except what it does is that when you have to deal with a missing key, a default dictionary will put in some sort of default object for you. So let's take an example of how it might work with a regular dictionary. So I'm going to run this first line of code, and oh wait, I need to hold on. I have to run the things above it. So run all above. So let's take a quick look at how this might work. So I'll start with two variables. One I'll call the regular dictionary, and I'll make it using the count function, which is a regular dictionary. And if I print out regular dictionary, you can see that I have 1, 2, 3, 4 keys, and each of them is associated with an integer. And if I ask for a particular key that I know is in the dictionary, I'll get a value. If I ask for a key that's not in the dictionary, I'll get a key error. But what happens if I do it with a default dictionary? So I'll call this default dict, and I will instantiate it using the cell from the right above it. And if I ask for a key that I already know is there, it'll return the value. And if I have another key that is not there, right? So I know that E was not in the dictionary, but when I looked for it, it didn't throw an error. What it did was instead, it added a new key to the dictionary, in this case, E. And the reason it's called a default dictionary is that when you ask for a key that's not there, it'll create a key value pair, and the value will be whatever the default value is that you've set. Now, in this case, we set our default dictionary to have an int or an integer. So if I ask for a key that's not in the dictionary, for example, F, it'll just put a default integer, in this case, 0. So if I ask for F, even though it's not there, what it'll do is it will create a new key value pair for F and the default, which is 0. So the cool thing about a default dictionary is that you can build up a dictionary piece by piece without having to explicitly insert the keys. So basically, a default dictionary is a dictionary where if you ask for a key that's not there, instead of throwing a key error, it will return some sort of default value. It'll create a new key value pair where the key will be the key you just entered and the value will be whatever the default value is. So that's a default dictionary. I hope that answers the question about default dictionaries. I think it was Elena who asked it. Now, Elena has a follow-up question, which is, is it possible to establish a different default value? In this case, not 0, but for example, new. Well, let's give it a try. So I'm going to change the programming here a little bit. Instead of default dict int, I'm going to try it with true. Let's see what happens. Or new. I'm going to add a string in new. Let's see if it'll do this for me. First argument must be callable or none. Oh, I know what the problem is. Hold on 1 second. So this would be str. And for element and count, it would be plus equal. So the way I would do it is I would create a string. And it would be an empty string. And I guess in this case, I could do new. Like, this is a little bit of a forced example, but I could do it this way. And for each time a value goes to the dictionary, it'll add new to a string. So in this case, I have my default dictionary. And if I do default E, it'll return a blank string. So I don't know if you can insert a ready-made string value, but you can insert like a blank string. Let's see if we can do it as a. Let's see here. Let me instantiate a new one that's outside of this function. So default dict equals default dict string. Let me just look at collections here. I could also do it as a Boolean. So let's see here. If I went to default dict key error A, it's going to give me an automatic false. Or B, it'll give me an automatic false. So you can do it with different things. It doesn't need to necessarily be an integer, but it would be something like an int, a string, or a Boolean. Imar wants to know if we can use an object in it. Huh, I had never thought of that. Let's try and see what happens. An object. Let me think about this for a second. All right, let's try something. Import pandas as PD. Pandas is a program that you'll be learning a little bit more about later. Default dict. I'm going to go with PD data frame. Huh, it does work. Let's see what happens. So default dict, there's nothing in it. It's going to be a default data frame. And then if I go default dict A, it does return essentially an empty data frame. So, yep, an empty data frame with 0 columns and no index. So yes. So Amar, to answer your question, yes. Rakesh has a question about Big O. I don't think we're going to have a chance to talk about Big O today, Rakesh. I would suggest looking at the videos for our last 2 office hours. Let's see here. For our office hours, yes, our last 2 office hours, we discussed Big O. Okay, we're going to move from default dictionaries to the PW mini project. So for those of you who are on the PW mini project, tell me what are the questions that you guys have regarding that mini project? Okay, Heisenberg is interested in question 1. All right, we're going to go over this. We'll go over question 1. So let me share my screen again. Okay, so the first thing that I'm going to do is I'm going to run all of the cells in the first part of the PW mini project. So I'll go to cell, run all above. And so this would be an example of what kind of data structure? What is this data structure? Make this a little bit bigger so you guys can see it. This is a dictionary, but I see a dictionary here and I see a dictionary here, and then I see that it's actually inside a list. So it's a list of dictionaries, and Graura is correct. This is an example of a JSON object, which for the purposes of Python is basically a list of dictionaries. So this is a JSON object. Kazibwe wants to know where the PW mini project is, and you need to go into data course, data wrangling, and then mini projects. Okay, back to PW. So our beneficiary data contains quantitative data on the number of items dispensed, the total quantity of items dispensed, and the net cost of the ingredients, and the actual cost. When you're working with a new data set, it can be useful to calculate summary statistics to get a feeling of the volume and character of the data. And so we need to figure a way to calculate the sum, the mean, the standard deviation, and quartile statistics for each of these quantities. And then we need to format it in a certain way so that we can pass it to the grader. Well, the first thing is, let's create functions for each of these things that we need to do. So I'm going to define a function. I'm going to call it define mean, and it'll take a list of values, which I'll call values. And it's going to return. So how do I get the mean? And I see some people are saying, well, we haven't gotten to the PW mini project yet. I think this is a good place to start for week 3, and then we'll go back and look at the VC mini project as well. So we should have time for both of those things. Now, how can I get the mean? Or what is the mean? How does one calculate the mean? And let's keep in mind that values is a list. So how does one calculate the mean of, Amara is right, it's the same as the average, same as the average. And how does one create that? How does one get that? If I have a list of values, If I have a list of values like these numbers, how do I get the mean of this list? One thing I could do is I could use the mean function. Well, it says mean is not defined. Mm, I could import. So one thing I could do is I could import NumPy, although we haven't looked at NumPy yet, so I'm not going to do that. Nitin has the right idea. I could take the sum of values, which in this case is 20, and then I would divide it by the length of the values. Another way that I could do it is I could import NumPy, and I could go np mean values, and that would give me the same thing. Or I could use the statistics as well. Since we're not dealing with NumPy yet, I'm just going to keep it here and do it this way. And then the other thing that I'm going to do is I'm going to just comment out some of the stuff here. Now, if I have this function, so this function does work. Let's see if this function works. So if I go mean values, I get my 4. So my mean function is now working. Now, the question here is I'm going to get in this, since I'm dealing with JSON objects, what I'm going to get is actually a list of dictionaries. And I don't want a list of dictionaries. If I'm going to calculate the mean of the values, I need only the values for one particular set of keys. So, for example, how can I get a list of only the items values? So if I look at scripts, I'm going to get these. And the question is, how can I get only, not just the items like the key value pair, but only the values? I just want a list of the values. Okay, so Adarsh has one idea. I could go scripts items. What happens there? I get a value, I get an error because the problem is that scripts isn't a dictionary, it's a list. But I think we're on the right track. So I have a list of dictionaries, and what I need to do is I need to get one value out of each dictionary. Amar has another good idea. So I could go scripts, and then I could get the index. So this 0 would be the first dictionary. And then I could put items here, and I do get one value, but I want to get all of the values. How can I get all of the values? And if I do scripts dot values, like Nitin says, I'm going to get another error because, again, this is a list. Scripts is a list that's full of dictionaries. So how can I get all of those values in all of those dictionaries? You guys are close. You're on the right track. I could try. So Nitin has an idea. Okay, so I get the first set of values, but again, I only want one value and I want it in all of the dictionaries. So Ariel and Florine have both excellent ideas, and they're essentially variations on the same idea, which is I can use a list or a list comprehension to cycle through all of the dictionaries. So let's say script is an individual dictionary, and I want the items value in, let's see here, for script in scripts. Let's see what this gives me. And indeed, I get a list, and if we just check it here, it should be 2 and 1, 2 and 1. This gives me all of the items values in all of the dictionaries. So what I'm doing is I'm looping through all of the dictionaries using this list comprehension. And for in each dictionary, I'm getting the items value, and then I'm storing it in this list. So if we take this knowledge and we go down to the describe function, the way to get our values is we take this and we paste it in here. And the only thing that we need to change is because we want this to not necessarily be limited to items, but rather to anything we pass, we'll change this to key. And the other thing I'm going to do is just do a little modification here. I just want to get a proof of concept. And I'll say return AVG, return average. Okay, let's try this. So I've created my function, and if I do describe and I pass in items, what I should get back is a tuple with a single value in it, which is the average for items. And actually, let's test it first. So I'll use my mean function, which I just created, and the list comprehension, which I just created. So I want to get 11.5. Let's see what happens if I do this here. I get 0. Interesting. Why do I get 0? Oh, excuse me. I know why, because I forgot to replace this part. So I need to go mean values. Okay, there we go. And I get 11.52. So what this function is doing, what the describe function is doing is it's taking a key. It then is getting the value for that key in all of the dictionaries that's in the scripts list. And then using the mean function, it calculates the mean. If I wanted to add, for example, total to this list, total would be the sum of all the values. So I would add total here. I'll put sum here. Okay, so 4,400,000. And I don't need an extra function. I can just use the sum here. And let's see if this works. There we go. And now I have my 2 items. So the way to tackle this problem is to use this list comprehension to pull out all of the values that you want from all of the dictionaries, then use some helper function, for example, mean, and you'd have to create functions for standard deviation and quantile. And then you would use those helper functions here to get the other values you need to get those tuples. So that would be my approach to problem 1 of the PW mini set. Now, Pauline says that the average is initialized to 0. I would add to that that this is just the way that the function looks like when it starts. But we, in fact, change that code so it's not initialized to anything. You just need to replace these zeros with your functions or your calculations. Are there any more questions about this question in the mini project before we go to VC? Okay, Adar says it's clear, so I'm going to move on. I'm going to close this notebook. And from there, I'm going to go to Data Course, Python, Mini Projects, VC. And let's get our object-oriented coding on. So, what questions can I answer for people about this mini project? So Pauline wants to get the mean of points in a cluster. Natine wants to learn about how to create an object. Joseph is interested in the distance. Okay, so let's start with distance before, and I think we can pick off some of the other questions as we go. All right, let me open up a new tab here. So let's say I have a plot. This is the x-axis, and this is the y-axis. If I have 2 points, one here and one here, and let's say this is 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So this point is at 6, excuse me, hold on, so this point in the XY space is at 2, 6, and this point is at 6, 2. How do I calculate the distance between these 2 points? How do I calculate the distance between these 2 points? Florin's right, it's kind of like Pythagorean theorem, because I think it's going to be hard for us to create our class until we know what it is we're trying to do. So Florian has a great summary of this, and I'm actually going to just copy and paste an address here into the chat and onto the screen. Excuse all the ads here, but here is the distance formula. So it's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. And Emmanuel is adding that this is called the Euclidean distance, and indeed it is. So what we need to do is we need to implement some sort of Euclidean distance function that would work for our point class. We need to expand our point class so that it has the Euclidean distance. And if we look at the, where are we? If we look at the distance here, yep, good. And if we look at the empty point class that's been supplied to us, there is a place where we're supposed to put in our Euclidean distance. Now, in the case of this, let's call our first point, we'll call this self. And we'll call this other. And we're not going to have a chance to go through all of this question, but if you guys tune in tomorrow, we can look at it more in depth, and then we can also move on to the k-means clustering. So if I want the square root, the first thing I need to do is I need to import square root, and that's already been done. So if I were going to type this out, it would be something like square root, and then I need to get the x and y coordinates, so I would do self x minus other dot x, and that refers to these items which are being, these attributes, these objects which are being passed in, and then I'm getting the x and y attributes. So next I would square that, and then I would add self.y minus other.y, and I would raise that to the second power, or square that. So that would be my square root function, and I would add return at the beginning so that it actually returns the value that I want. Now, there are some issues here that we need to just think about. The first is in our init function, I need to access these attributes, the x attribute and the y attribute. So I need to make sure that they're here in my init function. So self.x equals x and self.y equals y. So let's see if this works just by itself. Oh, wait, I got an extra. Let me just get rid of that. Actually, let me just put this in here. This is something that we saw in the videos, so I'm just going to copy and paste it in so we have the right representation. Okay, great. Let's try this. So, let's see here. Point. My first point is 2, 6. Okay. And I'll go dot distance. And here I'll put another point, and I'll say it's 6, 2. And there I get the answer, 5.65. So I know the answer is 5.65. So that's how I would calculate the distance. Now, there might be some other things you need to add here, but this would be a good start. All right. Can I answer any questions about what we've seen so far in the VC mini project and calculating the distance? Joseph says, thank you. Absolutely, Joseph. I'm happy to help. Adar says, frowny face, time is up. Adarsh, you are right. Time is up. And yes, it is a frowny face situation. So I know that we didn't get, Ariel says that was fast. I guess time flies when you're having fun, right, guys? So let's see here. I know Pauline and Rinky were asking about clustering and question 5 in the mini project. Unfortunately, we don't have time to deal with that today, but the good news is that we have office hours tomorrow, and the office hours are going to be 4 p.m. to 5 p.m. That's New York time. So adjust your hour accordingly. And until then, if you have any other questions, you can also put them in the forum. I've been seeing a lot of great discussion in there, people posting their questions, their code, and they're getting a lot of good answers as well. So if you don't want to wait 24 hours to talk through me, then what we'll do is, we'll deal with them here in office hours. Emmanuel asks, is there a Wawa you simplify concepts? I'm not exactly sure what you mean, Emmanuel, but if you want, you can maybe reformulate your question and I'll answer it in the chat window. But anyways, until tomorrow, I hope you all have a lot of fun with these projects, and I'm looking forward to continuing the conversation soon. Take care, guys.